Okay, so we're picking up with part two of proving triangles are congruent, and this is the slide we left off on. Our 5 ways of proving triangles are congruent: SSS, SAS, ASA, AAS, and HL. And now that we're familiar with what they mean, let's look at how they work in action. And we'll look at a few worked out examples, and then we'll do a few together. So in each of the following slides, there's a lot going on, but what you really have to pay attention to is the picture in the middle and then the result in the box. Everything else is going to stay the same. Right? Now, on the left, I'm keeping the list of 5 ways to do this. Process of elimination. If it doesn't match any of those, then we're going to say not congruent. And again, we want to focus on the picture in the middle and the result or the answer in the box. Everything else is kind of an explanation or directions. So if we look at our picture here, comparing our 2 triangles, the top is the original picture. The bottom is kind of my mental approach to doing this. I literally would label the picture S for side, A for angle, and then I would observe what I have against the list. And maybe I have to figure something out. We'll look at that in just a few minutes. So here, what I would do is I would take my original picture and I would say, oh, okay, well, let's see. Side 1 matches side 1. Now look at that picture. It's rotated. I do have to be careful here. Side 2, it's labeled with 2 hash marks, matches side 2. And then side 3 matches side 3. So we have SSS. There's no doubt these triangles are congruent by SSS. Now I have to write the congruent statement in corresponding order. So the first triangle, again, however I want. It doesn't matter. Do the first triangle however you want to. So I chose ACE. 1, angle 1, angle 2, angle 3, or corner 1, vertex 1, vertex 2, vertex 3. Now I have to match it in the second one. So I made angle 1 between sides 1 and 2. So I have to go to the second triangle and say, okay, angle 1 is between sides 1 and 2. So A came first, B comes first in the other one. I made number 2, or angle 2, between sides 1 and 3. So I have to do the same thing in the other picture. Since it's colored, I could say it's the angle between the purple and the green. But if it's not colored, if we're not using our colored pencils, that's okay. It's the angle connecting side 1 and 3. So in the other picture, I go angle between 1 and 3. So F is letter 2. C was letter 2, F is letter 2. And obviously, my 3's will match. So in this case, the picture was rotated or reflected, so I have to be a little careful, but I have to establish my pattern. And that's why we did all that work first, how to put things in corresponding order. So this is an example of how SSS works. Again, looking at our original picture, and at the bottom is my approach. So I looked at the picture and I said, okay, I have a side marked 1 and a side marked 1. I have a side marked 2 and a side marked 2. I have an angle marked 1 and an angle marked 1. I'm just looking for things that match, that I know are congruent. Now I'm going to look at this and say, does it match any of my options? Well, Look at the left triangle. I have two sides and the angle connecting them. In the right triangle, I have to have the same thing. Two sides and the angle connecting them. Well, two sides and the angle that sits between them, SAS. And then I would write my congruent statement in corresponding order. So the pictures have to match. Two sides and the angle between them matches two sides and the angle between them for SAS. Again, comparing our given picture to the way I would label it. An angle marked 1 and an angle marked 1. An angle with two arcs, an angle with two arcs. A side marked 1 and a side marked 1. So I have two angles and a side. Now, it's not the side between them. It's a different side. I have to make sure that these are the corresponding sides. So when I look at, in the first picture, if I look at segment AS, it's the segment going angle 1 to angle 3. I have to match that in the other picture, the segment connecting angle 1 to angle 3. That's good. So I'm going to say AAS. It has to be the corresponding side. In this case, it was the side connecting angle 1 to angle 3, or the third angle of the triangle. Now, look at the difference in the next example. Again, I have an angle marked 1 and an angle marked 1. I have an angle marked 2 and an angle marked 2. And I have a side marked 1 and a side marked 1. So again, I have two angles and a side. It's not the side between the angles, so it's not ASA. I have to make sure that it is the corresponding side. Well, KL goes from the angle 1 to the third angle. In the second triangle, my side goes from angle 2 to the third angle. Those are not the same. It's not the corresponding side. So these triangles are not congruent. It just doesn't fit any of our rules because it's not the correct parts. Looking at our picture here. Now, again, I just left the one picture. I didn't copy the picture a second time, but let's look at the way I labeled it. I always start with what did they tell me? They gave me angle 1 to angle 1. And they gave me a side marked 1 and a side marked 1. Process of elimination. Think about it as a process of elimination. Go down the list. I'm working with a side and an angle. It's probably not SSS. Now, I don't know for sure, but it's probably not SSS. I don't have right triangles, so it's not HL. So I can already cross 2 off. Now I have to figure out, I either need, because I have one A and one S, I either need another pair of sides or another pair of angles. And now it comes down to, what do I know? What can I figure out? Well, I can certainly figure out that we have a big X. There you go. I blew it up. I have a big X right there in the middle of the picture. And every time we have an X, we have vertical angles. So I know vertical angles are congruent. So I was able to add my own knowledge, chapter 1, first marking period, and identify another pair of congruent angles. So I know these angles right here are congruent. And now if I look at the picture carefully, I do have two angles and the non-included side. So the triangles are congruent by AAS. The side is from the vertical to the blank. The side in the other triangle going from the vertical to the blank. So we have to add our own knowledge. So we have to remember all of our first marking period material. Here we have vertical angles. Maybe we had parallel lines, and we can say the alternate interior or the corresponding angles. Every problem's different, but every problem's going to incorporate marking period 1 somehow. Here it might just be in naming the parts, naming the angles, naming the segments. Here it was vertical angles. It could be parallel lines, so we have to know those angle pairs. Let's see what we got. Let's look at another problem here. We were given side marked 1 and side marked 1. We were given a side marked 2 and a side marked 2. And that's all we have in the picture, so I'm going to stop and think. So far, I have two sides, two pairs of sides. Well, I don't have right angles, so it's not HL. If I'm going to use two S's, probably not AAS and probably not ASA. Now, I'm not saying it's definitely not, but I'm removing it from the list. Probably not going to use that rule. So it helps me focus. So now I either need the angle between the sides, angle S and angle N, which I have no idea what they measure, or I need the third side of the triangle. Now look at segment LP. Notice I marked it twice, and think about why. It is the third side of this triangle, of the bottom triangle, but it's also the third side of the top triangle. Whenever that segment is shared, use it, because LP from triangle 1 is exactly the same as LP from triangle 2. It's the same segment. It's certainly congruent to itself. We're just using it twice. And that serves as the third side of both triangles. That segment is being used twice, once for the first triangle and once for the second triangle. Whenever two triangles are connected to each other, the segment that they share is going to come into play. Expect it, look for it. Okay, this is a good example. We're shown the hypotenuse, and we have right triangles. So that's why I'm calling it a hypotenuse. Usually I would just label it a side, but since we have right triangle, it has a special name, hypotenuse. That's the only difference. Normally, I would label it S for side, but if it's a right triangle, it has a special name, hypotenuse. And now we're going to use the segment that the two triangles share. And that's where we're going to get our L's. So that's why we go with HL here. We could call it side and side, but it wouldn't match any of our rules. So remember, in a right triangle, sometimes we'll call them sides and angles, sometimes we'll call them hypotenuse and leg. It just depends. Every question's a little bit different. All right, so let's do a few on our own. Let's see what we have to start with. We have a pair of angles. So we have angle and angle. We have a pair of sides. So I'm going to label those S and S. And then we go through our mental checklist. Side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. Well, we don't have enough information to pick any of them yet. So now we go, well, what can we figure out? And what we should notice is in the middle of the picture is an X. So we have vertical angles. We have another angle from each triangle. Now we have enough to say AAS, and we can say triangle. I'm going to go VUW. Is congruent to, I have to match that pattern. So I went vertex, vertical angle, blank, 1. Whatever rule you want to, whatever pattern you want to establish. 2, 3, 1, vertical blank 1. However you want to do it, do the same thing for the other triangle. So again, vertical blank 1. So VMK. In number 2, an angle marked 2 and an angle marked 2. An angle marked 3 and an angle marked 3. A side marked 1 and a side marked 1. Well, look at it. It actually tells us. Look at the picture. It's 2 angles and the side between them on both triangles. It has to be the same for both triangles. And now I can write a congruent statement. So I might do triangle. I'm going to go 1, 2, 3. So Z, X, Y. And I'm going to match that with 1, 2, 3, NLM. Now the 1's not written in, but the 2 and the 3 are. So call the other one 1. Looking at our work here. An angle marked 1 and an angle marked 1. An angle marked 2, an angle marked 2. And always use the segment that connects them. So that's a side. DB is a side of the top triangle, but it is also a side of the bottom triangle. So we have ASA. And since we were asked to write a congruent statement, I'm going to go the top one, BDA, corresponding order. So BDA is 1, 2 blank. I'm going to go 1, 2 blank, D, B, C. 1, 2 blank on the bottom triangle. In number 2, we have sides match side, side match side, and the shared segment. So side matches side. So this is SSS. Triangle Again, there's multiple correct ways to write your congruent statement. There's 6 correct ways. Name the first triangle however you want, but the second one has to match. So I chose ADB, which means I have to follow it with ACB. Let's see what else we have here. Let's see, what do we have in this picture? We have an angle matches an angle, a side matches a side. The question is, can we figure out anything else? And they're not connected. We don't have a shared segment. We don't have parallel lines that we can figure out angles. We don't have vertical angles. There's just nothing we can do. We're going to say not congruent. And our last one here, very similar to one that we've already looked at. And this is congruent by SAS. Vertical angles right there in the middle. Naming the triangles, I'm going to say the first one, EIF. So I have to match it. Look at my pattern, EIF, and I'm going to match that with EHS. So let's see if we have any more here. Okay, all right. We will. Yeah, we'll do these two. So let's see. In our first triangle, it looks like we have. I have to fix that. We have a side 1 matches side 1, side 2 matches side 2, and we do have an angle that matches. Now, again, just because it's a right triangle doesn't mean that it's going to be HL. So I'm identifying them. Now I have to stop and think. Well, it's not 2 sides and the angle between them, and we don't have an ASS or an SSA rule. But it is a right triangle. So now I can think of, well, that means this can really be called a leg and a hypotenuse, and a leg and a hypotenuse. So now I do have HL. Right? I definitely do have HL now. And again, we're going to write that congruent statement. So I'm going to go UBT is congruent to, think about what it should be, UBT, right upside 1, and then out. So I'm going to go right angle is A, upside 1 to M, and then out to H. And in our last example, again, we have right triangles. So I'm already kind of thinking HL, but I don't know. I need to make sure. What do I actually have in this picture? Well, I have a pair of angles. I have a second pair of angles. I don't have any sides. It's not HL. I don't have any sides. I do have the vertical angles. So all I have is all 3 angles. Well, that's not one of our rules. Just because it's a right triangle doesn't mean it's HL. It doesn't even mean that they're congruent. We have to think, we have to process what parts we're working with. So here we have 2 right triangles, but they're not congruent. We don't know anything about the size. Remember, the angles control the shape. So these shapes are identical, but the segments control the size. We could have a really small right triangle and the other one could be big. We can't go based on what it looks like. We have to process the information that we have and the measurements that we have. So these are not congruent. All right, we're going to stop there and do some practice with proving pairs of triangles as congruent.